Alright, this video is going to take us through solving those equations that have a variable on both sides of the equal sign. So really quick, just to show you what that will look like, you'll have something like 2x minus 4 equals 3x plus 2. Okay, so what I want you to notice is that you have, on the left side of the equal sign, you have a 2x. On the right side, you have a 3x. So you have an x, or a variable, on both sides of that equal sign. Up until this point, we've only had one on one side or the other. Okay? So, quick little review of the steps that I've given you for solving equations. So first thing, very first step always, is the distributive property. So again, that's where you have your number, like a 2, times the quantity of x plus 3, okay, and that's where you take this 2 on the outside and multiply it by everything on the inside, so that becomes 2x plus 6, okay. Step 2, combine like terms, so anything that has the same variable, or if they're just regular numbers, combine those together. What we're focused here today in this video is getting the variable on one side of the equal sign. That's our focus today. And then step 4, get rid of your addition or subtraction. Step 5, get rid of multiplication or division. Okay, so let's just jump in and do some examples here. All right, so example 1, we have 2x plus 3 equals 4x plus 5. All right, I still want to go through those 5 steps that I've given you before. Okay, step number 1, distribute. Well, I don't have any sets of parentheses anywhere, so I don't need to distribute. Step 2 is to combine like terms. On this step, what you want to look for is the left side separately and the right side separately. So on the left, can you combine the 2x plus 3 and make it 5x? Your answer should automatically be no. The 2 has an x and the 3 doesn't. Okay, and then on the right, can you combine the 4x minus 5 and make it negative x? Again, no, because the 4 has an x, but the 5 doesn't. So we're jumping straight to step number 3. Get the variable on one side of the equal sign. Now, it doesn't matter whether you move the 2x over to the right or if you move the 4x over to the left. I always tend to want to move the smaller one, so in this case move the 2x. That way I don't have to deal with any negatives, and I know you may not want to do that either. So let's say I want to move the 2x, okay? I am not going to divide by 2 like you may think. If I divide by 2, all that does is cancel out the 2's, and I'm still left with the x. What I want to do is, since this 2x is positive, I am going to subtract 2x on both sides. Remember, you still have to do the same thing to both sides. And notice I'm subtracting the 2x, the whole portion of it, because I'm wanting to move the entire piece over. So my 2x's cancel, and I'm left with 3 over here, equals. Over here, 4x minus 2x is 2x, and then I still have the minus 5. All right. Step 4, get rid of your addition or subtraction. So I'm going to get rid of this minus 5 by adding 5 to both sides. So I have 8 equals 2x, and then the negative 5 plus 5 cancels. And then last step is get rid of this multiplication. Remember, this says 2 times x, so I'm going to divide by 2 on both sides. So 4 equals x. And there's my answer. All right, let's look at another one. Okay, let's say we have 7x plus 1 equals 8x plus 3. Okay, again, I should first notice that I don't have any parentheses, so I don't need to distribute anywhere. Step 2, I cannot combine 7x plus 1 and make it 8x because the 7 has an x and the 1 does not. And again, on the right, I can't make that 11x because the 8 has an x and the 3 doesn't. So straight to step 3, get the variable on one side. So again, I'm going to move the smaller one. I'm going to move the 7x. Since it's positive, again, I want to subtract 7x to get rid of it on both sides. 7x minus 7x is 0, so that cancels, and I'm left with 1. 8x minus 7x is 1x. Okay? But remember, you do not need to put that 1 with it, so I'm just going to take that away and leave it as x. And then bring down my plus 3. Okay, we want to get rid of that plus 3, so I'm going to do the opposite. I'm going to subtract 3 on each side. 1 minus 3 is negative 2 equals x, and then those 3's cancel, so x equals negative 2. All right, next example. We have 2x minus 7 equals 2x plus 10. Okay? So, there's no distributive property. There's no parentheses to deal with here. And I can't combine like terms because I don't have multiple sets of x's on either side. So the first thing I need to do is get that variable on one side, get the x on one side. Now, if you notice, they're both a 2x, so it's not going to matter which one you move. So this is positive 2x, so I'm going to subtract 2x on both sides. Now, watch and we'll see what happens. On the left-hand side, 2x minus 2x is 0. That cancels, and I'm left with negative 7 equals. On the right-hand side, 2x minus 2x is 0. That also cancels, and I'm left with 10. So notice your x's completely canceled each other out and went totally away. Now look at what I'm left with. Negative 7 equals 10. Ask yourself, is that a true statement? Does negative 7 equal 10? Are they the same number? And your answer is no, they are not the same answer. So when this happens and you're left with a statement that is not true, negative 7 does not equal 10, then we say that this has no solution. Okay? So what that means is, if you look back at this original equation, 2x minus 7 equals 2x plus 10, there is no number at all that you could plug in for x and then this equation work out to be a true statement. It doesn't happen. It's not possible. There's not negative number, not positive, not 0, nothing. Okay? If we go back and look at the example we just did, and I got x equals negative 2, that means that this negative 2, if I plug that in for x into that equation, it would work out to be a true statement. Okay? Again, back on this one, nothing is going to work. No number can be plugged into x and that be a true statement. Okay, with that being said, let's look at another example. Okay, this time I have 4x minus 12 equals 4 times the quantity of x minus 3. So your first thought should be, oh, there's parentheses. So we need to distribute first. So 4 times the x and 4 times the negative 3. 4 times x is 4x. 4 times negative 3 is negative 12. And then I haven't done anything over here on the left, so I'm going to keep it the same. All right, I can't combine anything. Next thing you need to do is get that x on one side. So I'm going to subtract 4x from both sides. Since it's positive 4x, to get rid of it, we need to subtract. Now, when you do that, let's see here, 4x minus 4x is 0. That cancels. And I'm left with negative 12. Equals, again over here, 4x minus 4x is 0. And I'm left with negative 12. So, similar situation, my x's completely went away. But now look at what I'm left with. Negative 12 equals negative 12. Is that a true statement? Yes, it is. So what we say for this one is we say that it has infinitely, you guys know what infinite means, many solutions. So really what that boils down to is there is any number you pick for x, anything. It could be positive, negative, zero, fraction, decimal, doesn't matter. Any number you plug in for x, it will work out to be a true statement. Okay? And if you notice, some of you might have caught this when we looked at this step right here. When you got here, you may have noticed that these were the exact same thing. 4x minus 12 equaled 4x minus 12. You may have noticed, hey, that's the same thing. Okay? So really, you're looking at two sides that are identical. Anything you plug in will make it true. Okay? Whereas the last example, this was not a true statement right here. So nothing you plugged in would work. That would be no solution. Okay, so again, we were looking at solving equations with variables on both sides. So if that variable was positive, you wanted to subtract it on each side. If it happened to be, let's say this happened to be a negative 4x, to get rid of it, you would want to add 4x to both sides.